Howdy everyone and welcome to our video on symmetry. In this video, we're going to be talking about, well, symmetry. Symmetry and its definition. Well, okay, you might know or have an idea what symmetry is from the past, right? It's when, like the left and right half of something are the same, like, well, my hands, right? But there's actually more to symmetry, especially in math. So let's go over that. Symmetry is an attribute of shapes in which a shape is mapped onto itself by a rigid transformation. What does that mean? Well, remember, mapping, like when we talked about congruence, right, is when I take all the points of a shape and line them up with corresponding points. So for example, if I was to make a triangle, A, B, C, and I was to reflect it, I would get another triangle of C prime, B prime, A prime. And all those points would line up with each other, right? Now, usually when we make a transformation, we make a new shape as the result, right? Like with tessellations, we would repeat a shape over and over and over and over, making new shapes that repeat. But now we're talking about mapping onto itself, so a shape that has internal repetition, right? It's like symmetry is like tessellation, but on the inside instead of outside, right? And it has to do it through rigid transformations, translation, reflection, or rotation. Well, translation doesn't make sense. To map it onto itself, you just get itself, right? Nothing interesting about that. But what about reflection and rotation? I think those will be interesting. So when we say mapping onto itself, we're saying take a piece of it and see if you can transform it to line up with the other half, right? Or another part. So the butterfly, for example, is reflectional symmetry. Why is that? Because if I take my butterfly, one half of it, I reflect that, and it gives me the other half of the butterfly. This line of reflection in the middle is what we call the line of symmetry. Okay? That is the line of symmetry. Now, not all things are reflectional, right? Like we've just seen. Some of them are rotational. So for example, these flower petals, I'm not going to do a very good job drawing them, and I apologize for that. But these flower petals are kind of like the propeller of a ship, which is what mine looks a lot more like, I apologize. And they are rotational. If I rotate this, they will line up with each other. You see, when it spins, they line up. So there's two transformations, two rigid transformations that I can use for symmetry, reflectional and rotational. And they both get special terms. Normally my line of reflection, now my line of symmetry. And normally my center rotation becomes my point of symmetry. So let's examine those in a little more detail to understand those definitions a little bit better. First of all, when I have something like the butterfly, one line, I'd call that the vertical line of reflection. I got to be careful. It folds horizontally, but it's the line itself I care about. So that's a vertical line of symmetry or a vertical line of reflection. You need to use the precise language. If you just tell me the middle, I don't know whether you mean vertically or horizontally or what, right? These are all middles. Now, one line will make bilateral symmetry because it divides it into two sides. One side of the line, the other side of the line, right? Bilateral means two sides. So two-side symmetry, bilateral symmetry. But there's ways to have more than one line of symmetry. For example, the flag of Jamaica can fold across the middle and down the middle, right? Vertically down the middle and across the middle horizontally, two lines of reflection, right? And again, you want to be more precise. So instead of down the middle, you want to say vertical line of reflection, and instead of across the middle, you want to say horizontal line of reflection, right? Now, rotational symmetry also has some other ways to see it. Here's the visual, much better for the flower. Now, it's going to be approximate. Biological things are never perfect like that, but notice it really, really closely lines up every 1/5 of the way around the circle. So after one full rotation, there were 5 times, including the end, that it lines up with itself. So that would be called 5-fold rotational symmetry. Now we can also divide the full sweep, 360 degrees, over 5 to say 5-fold in terms of what degrees do we have to cover for one lineup, which is 72 degrees. So in other words, we can cover 72-degree arcs that are all the same, right? If I split this into 5 pieces, each sweeping over 72 degrees, those pieces would all be the same as each other. Okay, so those are synonyms. 5-fold rotational symmetry is the same as 72-degree rotational symmetry. Now notice, While everything lines up with itself after a 360-degree turn, that is not symmetry. That's like one-fold symmetry. And if everything does it, it's not really important, right? If I say, I am thinking of a thing with 360-degree rotation symmetry, that tells you nothing because everything does that, right? So that's what we'd call trivial. It doesn't matter. That's not symmetrical, right? It's only when it has a degree less than 360 that we would look for it as rotational symmetry. Now, lastly, there are ways to have both kinds of symmetry. This plate, for example, has a vertical line of symmetry, right? Because it can fold across the middle, or if I was to break the plate in two pieces, both sides would be the same. It has a diagonal line of symmetry, right? Again, break it in half and they're both the same. It has a horizontal line of symmetry, another diagonal line of symmetry, the reflection of the other one, right? And it has rotational symmetry. If I was to rotate it, I can rotate it and stop 4 times, once for the end, right? And cover 90 degrees with each of the sweeps for 4-fold or 90-degree rotational symmetry. Many, many kinds of symmetry at once, right? So those are the kinds of symmetry and their definitions: reflectional symmetry and rotational symmetry, right? I hope that makes sense. Next video, our final video for topic 2, we're going to be talking about the properties of symmetry in regular polygons. I'll see you then.